Assalamualaikum Miss. My name is Muhammad MUZAMMIL bin Muhammad IRUSATH. Today, me and my fellow group mate, who is Muhammad DZULSHAHRIL bin DZULKHAIRI and Muhammad Hariz, are going to present about problem-based tasks for our network security course. So first of all, I'm going to start off with my part, which is NTP configuration. The first step is set date and time for NTP server. So you have to access NTP server, and then you have to set the current date. So for example, when I did this configuration, it was 22 May and the time was 5:25. All right. The second step is check RT1 if the clock is correct or the NTP service is enabled. So we have to check by running the command show NTP status. So in this case, the NTP is not enabled yet. And then you have to run show clock command to check if the time is synchronizing with this time or not. But in this case, we have not yet to apply the NTP server IP in this router. Okay. Now the third step is if it's not configured, type the command NTP server followed by the NTP server IP. So enter router RT1 and then you have to enter the command NTP server followed by the NTP server IP, which is 192.168.50.11. Okay. And the fourth step is check if the clock and date is correct. Check if it's synchronized. So before doing this, you have to fast forward it for a few times and then you need to check. Okay. So in this case, the time is synchronizing correctly. So let's check again. So it's 5:25 and then it took about 5 minutes to synchronize completely. So it's 5:30, and as the NTP server, it shows May 22, 2023. So let's verify it again. So May 22 and 2023. Okay. The fifth step is check RTA if the clock is correct or the NTP service is enabled. So pretty much we have to do the same command in all router. Okay. So let's start again. So show clock, and then as always, the time and the date is not synchronized, and you have to see if the NTP status is enabled. So obviously it's not enabled yet. The sixth step is if it's not configured, type the command NTP server followed by the NTP server IP, just the same as what we did in RT1. We have to type NTP server followed by the NTP server IP, which is 192.168.50.11. Okay. Then once we run this command, it will automatically after a few minutes, like 5 minutes, or you can fast forward it if you want. Show clock. Okay. So as you can see here, the clock is synchronizing properly. The date is correct. And if we run the command show NTP status, it says the clock is synchronized. The reference is the NTP server IP over here, which is .11. Okay, and then the eighth step is check RTA if the clock is correct or the NTP service is enabled. Okay, as you can see here, the NTP service is not enabled. So when it's not enabled, automatically the time and the date will not appear properly. Okay, not synchronized properly. Okay, and then once we run show NTP status, the NTP is not enabled yet. Okay, the ninth step is if it's not configured, type the command NTP server followed by the NTP server IP, which is the same command NTP server 192.168.50.11 is the NTP server IP. Okay, once we run this command, it will automatically synchronize properly and will show the clock following the NTP server and the date following the NTP server too. Alright. Clock is synchronized and the reference is 192.168.50.11, which is the NTP server IP. So now I'm gonna show in packet tracer. Okay. The last time I saved my configuration, I think the NTP server time is 6:30. But let's check again. Okay, 6:43. Okay. Okay, I'm gonna fast forward it and let's check in RT1. Okay. So we're going to check the clock. So, so you can check again in NTP server. Okay. So we can see that it says 22 May, which is correct. 22 May. And then the time is 6:46. Okay, it's exactly the same. 6:46. Now we're going to see the NTP status. Show NTP status. Okay, the clock is synchronized. So there is no problem in RT1. Now we can check on RTA. Okay. Okay, 6:46, May 22. Then MTP status. Okay, the clock is synchronized. Okay, so no problem in RTA. Now you're going to move on to RTB. Show clock. So it's 6:47 already. And then it's May 22, 2023. Show NTP status. Okay, so as you can see here, the clock is synchronized. The reference is 192.168.50.11, which is the NTP's server IP over here. Dot 11. Okay. Okay. So that is all for my part, Miss. The next part will be continued by Hariz, which is for syslog server configuration. Thank you, Miss.
Thank you to MUZAMMIL for the presentation. Now I will continue for this presentation, which is syslog server configuration. Before that, my name is Muhammad Hariz bin ZAHRULLAIL, and my matric number is 01-1F1029. So for the first thing first, we have to check on each router, which is RT1. We have to type show logging to see how many log drop and to check the thread login status. But if you see on the display now, by type show logging, there's no any information or configuration has been done on this RT1. And then for the next part, we have to check also to the IP server syslog server. By right, the syslog server use the IPv4 address which is 192.168.50.10 as an IPv4 address. And then after we configure the IP for the syslog server, we just configure to the RT1 by type by enter Google configuration mode, and then we have to type the login to the IP syslog server, which is 192.168.50.10, and then we also have to add syntax service timestamp, log date time, msec, and then login trap debugging. This command will add the timestamp to each log entry and then to set logging level to debugging. After that, just tap exit and the syslog service is started. When you see this information look like, that means the syslog service is started. And then it will be recorded to the syslog server. And this command will enable debugging, especially for IP ICMP. On this same router, which is RT1, we have to debug IP ICMP. When the ICMP packet debugging is enabled, the information will appear as this page. And then we have to retype show login to verify how many message log drop and to check the thread login status on this RT1. So after we retype show login, the information of the configuration that I have done on this RT1, which is logging or debugging here, there's information to the syslog server IP address. And next, we have to define to the next router, which is RTA, and then we just type a show login to see how many log drop and to check trap login status on this RTA. By right, the RTA has been not configured yet, and then we just go through to the configuration, which is we have to login to the IP syslog server, which is 192.168.50.10, and then we just add the service timestamp, log that time and check, and then logging trap debugging. So if you type exit in this on RTA, the syslog service is started, and then the information looks like as this page appear. So that means the syslog service is started and be recorded to the syslog server. And then you have to debug also for the IP SMP. Once you enter the command, the ICMP packet debugging is on or enabled. And then we just verify same as RT1, which is show login. So the information of the configuration that have been done on RTA before has been appear on this show login information. So we go next to the next router, which is RTB. which define us by show login. So as you can see, there's no any configuration or trap login status. And then we just configure first on the RTB, which is login to IP before syslog server. And then we just add a service timestamp, log date type msec, and then login trap the debugging. And then just type exit to enable the syslog service. Once the information on date has been appeared, so that this log has been recorded to the syslog server. And then we just debug for the IP ICMP. When the ICMP packet debugging is on, the information will be appear. And then we just retype the show login to verify how many log drop and to check track login status. We just show login, and then the information based on the configuration that have we create before has been recorded on this RTB, which is the logging, thread debugging, and then the two message line has been recorded. Now let's go through to the output of the syslog, which is a capture, log, and a flow monitoring. So we go first to the capture log, which is a syslog server. So after we go to the syslog server, and then the service is on, after we configure the configuration before on RT1, RTA, and RTB, then the log of entry has been recorded on this syslog server. As you can see here, this is for the first one feature. This is mean before we configure the syslog server. And then after we configure on a RTA, which is on this example, we do it on RTA. After we turn off the interface by L001 and RTA, so the syslog server will be recorded on this location. So by hostname, we can define the from each router or RTA has been recorded. So for the next, this is extra 7 log entry after ping from RTA to RT1. So as you can see here, the hostname that defined is this for the RTA by record that for the ICMP, and then the login status and timestamp on the syslog server. So I think that's all for me. I will pass to my partner, which is Tizel, to continue this presentation. Thank you.
Assalamualaikum and salam sejahtera to Puan Rosita. My name is Muhammad DZULSHAHRIL bin DZULKHAIRI and my registration number is 01DDT21F1023. So first of all, I want to say thank you to Muhammad Hariz for the presentation. So I will continue for our team presentation. So which I will continue part for NetFlow server configuration. So first thing first, uh, we have to NetFlow server IP addressing. So here you can see in the picture, there is our IPv4 address, subnet mask, default gateway, and DNS server. So for the IP for the NetFlow server is .12. So next configuration is turn on the NetFlow collector service in NetFlow server. So in the picture, the NetFlow server on the NetFlow collector service are on. So next, name the flow expector as my flow X. The destination IP is NetFlow server's IP, and it use transport ADP 9996. So here is the configuration for on the RT1. So next, flow record name is record 1. Match the IP before source address and destination address. Match the protocol source port and destination port. And lastly, match the IPv4 protocol. So in the picture, you can see the configuration on the RT1 that is for configuration for NetFlow. So here I have been say on the step 4. So for the step 5, you can see here collect timestamp first and last, and then collect transport TCP flags, collect counter bits, collect counter packet, collect interface input, collect interface output. This will be in your the NetFlow collector on this net flow collector, it will appear the chat pie. So it will say like this. You can see the IP before, IP before for destination and source, and anything and other else. And next step is assign record 1 record and my flow X expector under Moon 1 flow monitor. So here you can see the configuration of RT1 for your flow monitor Moon 1. You assign the record read 1 and expector my flow X. So the last configuration is assign flow monitor Moon 1 on S serial 000, serial 001 and gigabit 00 interface. So you can see in the picture, I every on the serial 000 put the Moon 1 input and serial 001 you can put Moon 1 input. So in the last interface gigabit 00 Moon 1 also Moon 1 input. So for the verification for NetFlow server after all the configuration is signed, so this is how it look when you have been doing something configuration verification like web server or ping or other protocol. It will appear like chat pie. So if you want to verification the NetFlow, so you can first you can go to any PC like PC A2 access to web server. So here you can see www.xyz.com. So it's successful uh, access the web server. So when you access the web server, you can see like here, the IP address from the source address is from PC A2. So the destination address will be the web server www.xyz.com. You can see here it will be it's then list the IP address for web server. So this is for the IP address for PC A2. So here you can see in the picture it appeared all the details that when the PC A2 access to web server, it will appear, and you can see the source port, destination port, HTTP, IP protocol, timestamp first and timestamp last, TCP flag, counter beeps, counter packet, and interface input will be serial 000, interface output will be serial 001. So other than that, you can use the protocol ICMP, which is ping. So here you can see PCA2 ping to DNS server. So you can see this is the IP address for PC2A. So in the picture, you can see the IP address source is PCA2. Destination address is for the DNS server IP. So you can see the source port and then destination port is DNS 53. The IP protocol timestamp first and timestamp last, TCP flag, counter beeps, counter packet, and interface input is serial 000, interface output will be gigabit 00. So that is all for the verification for NetFlow. So it successfully completed and success, and all the configuration is success. That is all from us. Thank you for watching.